The following program is video supplemental instruction. VSI is brought to you by the Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.
Okay, so I wanted to just go over some things to know before you go and try to work through the problems for Physics 2020 midterm exam. And the reason why I wanted to go through some of these things is because it can get kind of confusing when you're trying to work through problems and you get confused with what sign that you're supposed to use. Remember, in physics you deal a lot with vectors, and vectors are quantities that have both magnitude and direction, and the negative, so basically you can have something, for example, like velocity, which is a vector. The sign will indicate whether or not something is moving, it basically is moving to the right or to the left, will indicate the direction of the velocity. Same thing with force. Force is also a vector. It has a magnitude and it has a direction. So a lot of times when you're working through physics problems, if you don't use the right sign, you may end up getting an incorrect answer. And so I wanted to go through some things to know in order to make it more clear as to when to use a negative sign, when to use a positive sign for the problems that you're going to see in Physics 2020 Midterm Exam 1. Alright, so the first thing that you need to do, so the first thing that you need to know is that you need to set up a coordinate system. Okay? And that means basically when you read the problem and you're trying to get an understanding of a problem, you're going to try to work through it, you need to define what your coordinate system is going to be. And conventionally, we typically just set up our Cartesian coordinate where we have the positive x direction going to the right, and we have the positive vertical direction y going up, where this would be the origin. Now, there are some problems in physics and also in math where it makes more sense to redefine your coordinate system in a different way. But at this particular level, for most of the problems that you're going to work through, especially for the problems in Physics 2020 in this midterm exam, I encourage you to try to use the conventional way to set up the coordinate system in order to work through these problems. Okay? And once you set up a coordinate system, that means that everything, every parameter, every variable, every piece of information that's given in a problem needs to be consistent with this coordinate system. So, for example, if I said that that this is the coordinate system, and I'm starting at an initial height of 300 meters, and I want to find the time of an object that's going to fall to the ground, then that means that my initial height, right, would be equal to 300 meters, and my final height would equal to 0 meters since I wanted to hit the ground. So that if I want to find delta y, which is the change in the height, that's going to give me a negative value, right? Because I have the final minus the initial, which is going to be negative. All right? That might seem a little weird to you that you have a negative height, but indeed, that's not weird. What that is saying is that that's a result of the way that we set up the coordinate system. And when you work through problems, if you don't have that negative sign there, a lot of times the problem is not gonna, you're not gonna be able to work out the problem correctly. All right. Another important thing that we need to talk about, and it also has to do with the coordinate system, is dealing with gravity. Okay, so let's look at things moving in a projectile motion. All right, so this is things to know number 2. So you're given a formula sheet for this particular exam, and if you look at the equations in the for projectile motions, you'll see in particular the sections for the sub equations for things moving in the y direction. And you'll notice that initially it tells you that ay, the first equation, is equal to minus g. All right. What that really means is that gravity, g, is a acceleration. Acceleration is a vector, so it has direction, has magnitude and direction. And so what does the minus and plus sign actually mean for gravity? Well, we know that gravity is always acting down on an object, okay? The question is whether it's going to act to speed up the object, which is accelerate the object, or it's going to act to slow down the object, which is decelerate on the object. And so that's where the negative sign comes in for gravity. Typically, when you're throwing something up in the air, the gravity is actually going to act to slow that object down, right? It's going to initially thrown up into the air, the object is going to slow down, come to a stop, and then come back down. So we would say that gravity initially is acting with a negative sign because it's acting to slow that object down. Now, if you're starting, let's say, on a 300-meter tall building and you're dropping a ball down, then what's happening? Well, the ball is going to drop initially from rest, which is going to have a velocity of 0, and then gravity is going to act on that ball. It's going to slowly accelerate that that object, and so that's going to act to speed up the object. So that's going to be a positive gravity. All right, so let's summarize what I just said. So we know that positive g means that gravity acting to speed up object. Okay? And negative gravity means gravity acting to slow down object. Okay. So how do we use this in our formulas? Okay. So taking a look at these equations again, if I can get to them. Again, looking for projectile motion, and there are 2 equations that we want to look at in particular. The one we have, Vy is equal to V sub 0 sine theta sub 0 minus G time for time. Now, what you need to know is that this equation is true. But this equation, first of all, assumes that we have our coordinate system defined in this way. Okay? And so if we do that, this equation is already taken into the account of decelerating an object for negative gravity. So that's why there's a negative sign here already. So typically this equation is written like this. Where we have a plus sign in the equation instead of a negative sign. We have a plus sign here. When you have a plus sign here, you have to be mindful of what direction the gravity acting on. Is it acting to speed up an object or slow down the object? But when we have the negative case, we're already taking into account that it's acting to slow it down. So in here, you're going to, if you're going to use this equation, which is the equation on the sheet, you don't need to substitute in negative, right? You need to just substitute in positive 9.8 meters per second squared, or positive gravity, okay? Because if you substitute in a negative, it's going to make this positive erroneously, right? Because we're already accounting for the negative in this equation as is given. If you use this equation, then we'll need to substitute in a positive or a negative meters per second squared, depending on your coordinate system and what it says in the problem. Okay? So just understand that this equation is already taken into account for negative gravity. So when you substitute in G, just substitute in positive the value for gravity, which is 9.8 meters per second squared, or 32 feet per second squared if you're talking about the British units. Okay? The other equation that's basically the same thing is if you have alright, this equation is also on the formula sheet, and it also takes into the account of negative gravity here. Okay? So in this particular equation, you just want to substitute in, again, positive 9.8 meters per second squared. Alright? You don't want to substitute in negative because you're already taking that into consideration in the equation itself. But if you had this equation, okay, what that does is now you need to either substitute in positive or negative 9.8 meters per second squared, depending on, again, your coordinate system and the problem statement, what the information is given into the problem, okay? And if we know that gravity is acting to slow it down, we want to use negative. If it's acting to speed it up, then we want to use positive. All right, so those are just some quick things. We have one more thing that I want to go over. So the third thing is the range. We denote that as R. All right. Also under projectile motion section, it defines the equation for range is equal to v sub 0, so your initial velocity squared times the sine of 2 times your initial angle divided by the gravity. Okay? And this equation is valid only if, so only use if your initial y is equal to 0. Okay? So basically, if you're trying to find, let's say that you have a, you see a person here, and they're throwing an object. Let's say they're throwing an object up, and let's say that this is the ground, right? And let's see here. Okay. All right. And let's say we want to determine, basically the range is defined as the distance that an object travels when you initially launch it in some sort of projectile motion, and when it reaches, basically, when it reaches, some point. Okay, this is only true if we can only use this equation if our initial y is 0. So we know that if we define our coordinate system in this way, right, our initial y is going to have some value, right? It's going to have some value, some number that's not equal to 0. Okay, since this we define as 0. So you would not be able to use this equation. The equation that you need to use when y doesn't equal to 0 is this. So range in this case is going to be alright. So basically, this is the equation that you're going to use. So use if your initial y does not equal to 0. And I just want to note that if you want to see an example of this, so, see problem number 4, okay? See problem number 4, the VSI video, okay? And I go through an explanation of when we want to use the situation where, we don't want to erroneously use this equation that's given on the formula sheet. Instead, we would use this equation because our initial y doesn't equal to 0. I go through an example of that. So see problem number 4 if you want to get that information. Right? Good luck.
The Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.